Hello Math 30. Today we're going to look at the second part of discontinuity with rational functions. Last class we looked at asymptotes. Today we're going to look at something called the point of discontinuity. We briefly brushed upon it in the beginning of this lesson. So this one right here is going to have an asymptote at x, a vertical asymptote at x as x equals to 3. This one right here is not going to. I'm going to explain why. And this one here, when we simplify this, I cannot divide this by x subtract 3. This is not a factor of that. Here, this is, because this can be factored as x minus 3, the top, the numerator, and x minus 1. And then here we're going to have x minus 3. So basically, these could divide each other like that. And if I was to graph this in my graphing calculator, it would just look like x plus 1, except that x minus 1, but at, here's my graph, except at x minus 3, so at 3, we're going to have a little hole there. Okay, so let's take a look at it. I'll show you right here quickly. Calculator, graph, clear it. So we're going to put this all in brackets, all the top in brackets and all the bottom brackets. So I'm going to put x squared, clear first, bracket, we have x squared minus 4x, then we're going to plus 3. Then we're dividing that by x minus 3. So I'm going to have x in brackets again, x subtract 3, and close my brackets. Now let's graph it and see what it looks like. I look at it there, our line goes across, but we should have a point of discontinuity. Whoops. Okay, so where is my point of discontinuity? If I put trace and I put 3, I have no y value. If I zoom in at that point, right here, eventually if I zoom in enough, there's going to be a little break in there. So we have at 3, and I keep on going, but there is a slight break at 3 somewhere. If I trace, I can never hit 3. All of a sudden, it's not there. So that's why we'll denote that with a line, a little break, like that. Because it cannot equal to 3, as we said before. Here, on your graph, it looks like it equals to 3, because it gets infinitely close. It just cannot be that little speck. Okay? Now, let's continue this here. I'm now going to skip this part here and show you the last one, because this is just for you to do, and we're going to work on the class example here together. So this one here says, consider the rational function, write the numerator of the function as a product of 3 binomial factors, hence express it as simplest form. So we first want to see if this could divide that. Alright? So I'm going to do my division that we learned a while ago. So what we have here is 1. Because x equals to 1. And then we're going to have 1. Now how many x squares there are? There is 0. Then we have negative 7. And then we have 6. Okay? So we go 1 times, we bring down the 1. And we go 1 times 1 is 1. Now I have to add these together. I'm going to get 1. 1 times 1 again is 1. Add these together. I'm going to negative 6. 1 times negative 6 is negative 6. Add these together. I'm getting 0. So there's 0 remainder. So then we know now that x minus 1 is multiplied by, this is x squared, x, and negative 6. If you remember the division, or we could do long division if you prefer that. Now I look at this, we know for a fact that x minus 1 divides it. So our formula would look like this, x minus 1 multiplied by x squared plus x minus 6 all over x minus 1. These would cancel off. So we'd just be left with x squared plus x minus 6, which is the same thing as x minus 3, or sorry, minus 2, x plus 3. Okay, if we factor them. Alright, so those would kind of cancel off. But we also know that x cannot equal to 1. Alright, so this is what's left, with it, which is a parabola, but x cannot equal to 1. So now it says determine the coordinates of the point of discontinuity. Well, that is at x when x is equal to 1 is my point of discontinuity. Now, what is the y value of that? I'm going to have to plug it into my equation. So we're going to plug it into this equation here. All right? So we have 1 minus 2 multiplied by 1 plus 3. Let's figure out my y value. I get negative 1 multiplied by 3 is going to give me, or multiplied by 4 is negative 4. So it's at 1 comma negative 4. Sorry, there, had a little bit of a cough. And that is my point of discontinuity. Okay? Now it wants us to state the zeros of the function. So what are my zeros? Well, it's just that. My zeros are, remember, we have x minus 2 is equal to 0. So we have x, because on the denominator, in factored form, x is equal to 2. And the other one is when x minus 3 is equal to 0. So x is equal to negative 3. So those are my two zeros. So I have at 2 and negative 3. And my point of discontinuity is at 1, 4. Okay? Now, use a graphing calculator to graph it on the grid. So we know also at 1, negative 4, right there is going to be 1. So I'm going to put in x squared. And we said, where was it? Plus x. And then I'm going to minus 6. And we graph it. Right? So there's my graph. But we know at 1, 4, my graph is going to look something like this. And we have our discontinuity there. So it looks something like that there. And this is at negative 3, and this is at 2. Okay? And that's how we do that. So here in example 2, we know it says the graph of this function is a straight line with 2 points of discontinuity. We want to algebraically show where the straight line is. What is the equation of the straight line? So to start off, I am going to factor my denominator. Okay? So we have 2x squared plus 7x plus 5. Well, I factor that, go 10, and that's going to be 2 and 5. So 2 divided by 2, so it's going to be x plus 1. And I'm going to end up getting, for the other one here, will be 2x plus 5. Okay? Now that this is done, we're going to see where these divide those. And we know they should. So we're going to divide first. I'm going to do the x plus 1. So I'm going to, now, step 2 is divide using synthetic. So step 1 was factor denominator. Step 2 is divide. Okay? So I'm going to have negative 1. X cannot equal to negative 1. And x cannot equal to negative 5 over 2. So we put negative 1. Go that way. Right? There we go. Now, we have negative 1. And everything here, we're going to have 2. And we have a 1, negative 16, and negative 15. Okay? Bring down 2. Negative 1 times 2 is negative 2. Add those, I'm going to get negative 1 is going to be 1. Add these together, I'm going to get negative 15. That's going to give me 15, which is 0. Okay? Multiply those. And so I'm left with, here we get 2x squared minus x minus 15, and that's all multiplied by x plus 1. Now our next one wants us to do this. So I could do that again. Or I could try and factor this now because it's an x squared. So I can multiply this. 30, well that's 6 and 5. Okay? So 30 is 6 and 5, and 6 can be divided by 2. So I'm going to have x plus 1. And I'm going to end up getting, when I factor this, I'm going to get x minus 3, and then 2x plus 5. Okay? And that's it, because this could be factored. Then, number 3 is factor. So, what do we know cancels off? If I write this, then cancel. Step 4 will be cancel. We have x plus 1 x minus 3 multiplied by 2x plus 5. And this is all going to be over, we have x plus 1 over 2x plus 5. Now, we look at this. This cancels with this. This cancels with, oh, that should be plus 1. This cancels with that. So, we're left with x minus 3 is my equation of the y. Okay? Now, part B is determine the coordinates of the points of discontinuity. So now we want all the coordinates of the points of discontinuity. So the first one is at negative 1. So we put f of negative 1 is equal to negative 1 minus 3, which is going to be equal to negative 4. Okay? My next one is at 5 over 2. So I'm going to put in 5 over 2. So f of negative 5 over 2, which should give me negative 5 over 2 minus 3, which is going to end up giving me negative 11 over 2. Okay? And so now we know we have negative 1, comma, negative 4, and negative 5 over 2, comma, negative 11 over 2. Those are my 2 points of discontinuity. Next is make a rough sketch of the graph from our answers. Let's make a rough sketch. So I know negative 3, that's my y-intercept right there. And we have negative 1, negative 4. So here's 1 point of discontinuity. That's going to be negative 2.5. And that's like more. And there's going to be my other one. So my graph is going to look like this. Okay? And this here is going to be at, oh, this value here is going to be 3. This value here is negative 5 over 2, comma, negative 11 over 2. And this point here is negative 1, negative 4. All right? So that's everything. Good luck. Hopefully you understood that. And I'll see you tomorrow as we work on this together.